Yes, we are in live now. So, good afternoon, everyone. I request all of you to kindly share this live session and as well as like this session. I repeat, hello everyone. Those who are in live now, kindly share this live session and as well as like this session. তো যারা যারা লাইভে আছো কাইন্ডলি আমাকে একটু বলো যে আমার অডিও আর ভিডিও কোয়ালিটিটা একটু ঠিক আছে কিনা। ঠিক আছে, তারপর আমি বলা স্টার্ট করছি। যারা যারা লাইভে আছো সবাইকে গুড আফটারনুন। আমি অনেক দিন এই এন্ট্রান্স ক্লাসের ভিডিও দিতে পারিনি, আমাদের কিছু টেকনিক্যাল কিছু ইস্যু ছিল, তার জন্য ক্লাসে আসতে পারিনি। তো এক্সট্রিমলি সরি ফর দিস। তো আশা করছি এবার থেকে যে ভিডিওগুলি আসবে তোমরা সহযোগিতা করবে সবাই। আর সব যারা যারা লাইভে আছো প্রত্যেকের কাছে একটা রিকোয়েস্ট, সবাই চট করে একটু লাইভটাকে শেয়ার করে দাও। তো চলো শুরু করি। সো হ্যালো এভরিওয়ান, দিস ইজ সুব্রজিৎ and welcome to the symbiosis the wing of artophony. ওকে, তো তোমরা থাম্বনেল দেখে বুঝতে পারছো আজকে বেসিক্যালি কোন চ্যাপ্টারটা নিয়ে বেসিক্যালি ডিসকাস করব। ঠিক আছে, তো আমার প্রিভিয়াস যে ক্লাসটা ছিল সেটা ছিল বেসিক্যালি ইউনিটস অ্যান্ড মেজারমেন্ট। ঠিক আছে, তো যারা যারা জি এবং নিট এক্সপিরিয়েন্স আছো তাদের জন্য খুব খুব ইম্পর্টেন্স কিন্তু চ্যাপ্টার। ঠিক আছে, এবং অ্যাজ ওয়েল এজ আজকের যে চ্যাপ্টারটা এররস ইন মেজারমেন্ট, এই চ্যাপ্টারটা থেকেও কিন্তু জি এবং নিটে প্রতিবারই কিন্তু এই চ্যাপ্টার থেকে কিন্তু কোশ্চেন কিন্তু থাকে। সো ভিডিওটা লাস্ট অবধি দেখতে থাকো তোমরা, আশা করছি ভিডিওটি তোমাদের খুব ভালো লাগবে। ঠিক আছে, সো যারা যারা লাইভে আছো তাদেরকে আবারও গুড আফটারনুন। আর তোমরা ক্লাস থাম্বনেলটি দেখে বুঝতে পারছো বেসিক্যালি আজকে যে ইম্পর্টেন্ট চ্যাপ্টার, যারা যারা জি এবং নিট এক্সপিরিয়েন্স আছো প্রত্যেকের জন্য বলছি, এই এররস ইন মেজারমেন্ট খুব খুব ইম্পর্টেন্ট কিন্তু চ্যাপ্টার, প্রত্যেকের জন্য বলছি, ঠিক আছে? তো চলো শুরু করছি। So let's start. So first of all we want to know that what is error. So you see, so error is the result of every measurement by any measuring instrument contains some uncertainty, which contains some uncertainty, and this uncertainty is called error. Understand? So we see the result of every measurement. We get after the measurement we get some results. So that say that the result of every measurement by any measuring instrument contains some uncertainty, and this uncertainty is called error. Okay? And you see, every calculated quantity which is based on measured values also has an error. Got it? So every calculated quantity which is based on measured values, that also has an error. Got it? And here also we discuss two important topics, that one is accuracy and the other is precision. Got it? So first one is accuracy and the second one is precision. Okay? So we see what is accuracy and what is precision. Okay? So let's see. So say accuracy is, that said, the accuracy of a measurement is a measure of how close the measured value is to the true value of the quantity. Got it? So here accuracy says the accuracy of a measurement is a measured value. That measured value how close to the true value. Okay, here two value. One is measured value and the other is true value. And we see that one value, that measured value is how close to this true value. Okay, and that thing is accuracy. Got it? And the other thing is precision. So see what is precision. So you see, precision tells us what resolution or what limit the quantity is measured. Here two things you see, one is resolution and or limit. Okay, that precision also tells us what resolution or what limit the quantity is measured. Okay, and you see some example, that after that will be clarified. Okay, you see one example here. So see, here said the true value of a certain length is near about 3.678 centimeter. That is the true value of some certain length. And in one experiment using a measuring instrument of resolution that like 0.1 centimeter, the measured values is found to be how much? 3.5 centimeter. Here you see the resolution is about 0.1 centimeter and the measured value is 3.5 centimeter. And in another experiment, using a measuring device of great resolution, say that like 0.01 centimeter, okay, 0.01 centimeter, that is much near about zero, okay. So when the resolution is near about 0.01 centimeter, the length is determined to be how much? 3.38 centimeter. But when in experiment number 1, when the resolution is 0.1 centimeter, then we found to be the measured value is to be 3.5 centimeter. Got it? But when in another experiment, when the resolution say about 0.01 centimeter, then the determined measuring value is to be 3.38 centimeter. So we say that the first measurement has more accuracy, but less precision. Got it? So the first measurement said that measurement has more accuracy but less precision. ठीक है? Why? In the second experiment, we see that the second measurement is less accurate but more precise. Got it? So in this example, we see that two experiments, and from these two experiments, we conclude that the first measurement has more accuracy but less precision, while in the second measurement, the measurement is less accurate but more precise. Okay. Now we see another example. Okay. So let's see. So you see this figure. This is like bull's eye. Okay. You people already see that. This suppose this one is bull's eye, and here 4 cases. We take 4. We have taken here 4 cases. Got it? So in the first case, you see the target in the bullseye is in the medial portion of the bullseye, and that case we say that case is more accurate and precise. Okay, because the target is in the center of the bullseye. Got it? This target. Got it? And you see in the second case, the target are randomly here in the bullseye, and that case we say that this is accurate but not precise. Got it? In the second case. And you see in the third case, the target are here in the bullseye. This is the center, and the targets are here from the center. So this case we say that this one is not accurate but precise. Okay. And in the fourth case you see that the target in the bullseye all are randomly situated. You see, all the target are randomly situated, and this case we say that this one is not accurate and also not precise. Okay, so I think you may understand what is accuracy and what is precise. Okay, so in these 4 cases, in the first case we have seen that this one is accurate and as well as precise, and in the second case this case is accurate but not precise, and in the third case we say that this one is not accurate but precise, and in the fourth case you see that that case is not precise and as well as not accurate. Got it? I think you may understand both accuracy and precision. Got it? So this is the accuracy and precision. I think you may understand what is accuracy and what is precision. Okay, so next, see, so here you find two types of errors. Okay, when you measure some errors, you may find two errors. First one is systematic errors and the second one is random errors. Okay, so we have got two errors. First one is systematic error and the second one is random errors. Okay, so we see what is systematic and what is random errors. First see what is systematic error. Okay, so you see the systematic errors are those errors that tend to be in one direction, either positive or either negative. Okay, so let's say that the systematic errors are those errors that tend to be in one direction, either positive or either negative, in only one direction. Okay, Achha. So the question is, what is the reason of systematic error? So see, what is the reason of this systematic error? So you see, first one is instrumental errors. First one, that some instruments already have errors, and the second one is imperfection in experimental technique or procedure. Okay, and the third one is personal errors. Okay, and there we have got three reasons of systematic errors. Okay, first one is instrumental errors, second one is imperfection in experimental technique or procedure, and the third one is personal error. Okay, so now let's discuss these errors. So first one is instrumental error. So let's see what is instrumental error. So these type of errors basically arises from the errors due to imperfect design or calibration of the measuring instrument. Got it? Due to imperfect design or calibration of the measuring instrument. And for example, you see the weight measuring machine. You see already see that this figure. This is the weight measuring machine. We already have seen or already known. So instrumental errors, example of instrumental error is weight measuring machine. Got it? Next one is imperfection in experimental technique or procedure. So let's see what it is. So you see, to determine the temperature of a human body, a thermometer placed under the armpit will always give a temperature lower than the actual value of the body temperature. Okay, and that time this type of errors, basically imperfection in experimental technique or procedure, this type of errors has arisen. So I say that to determine the temperature of a human body, a thermometer always placed under the armpit of a body will always give a temperature, and that give some lower temperature than the actual temperature of the body temperature. And you see that figure. Sorry. You see that figure that this is the thermometer, and this thermometer placed under the, this is the arm, okay, so under the armpit of a body. But that time what happened, the temperature are lower than the actual temperature of a body. Okay, now see the third one. So the third one is personal errors. So let's see what it is. So you see this type of errors means personal errors that arises due to an individual bias, lack of proper setting of the apparatus for individual carelessness. Okay, individual carelessness in taking observation without observing proper precautions. Got it? So you see that thermometer, and in this thermometer you see that arises due to an individual bias, lack of proper setting. Okay, when you have not proper setting this thermometer, then this type of errors will arise. Okay, this type of errors will arise this time. Okay, so here that said that that arises due to an individual bias, lack of proper setting of the apparatus for individuals carelessness in taking observation without observing proper precautions. Okay, and that type of errors is personal errors. Okay, so this type of errors is personal errors. Okay, I think you may understand this the reason of systematic errors. Okay, now let's see the next thing. So, and the next error is random error, the second type of errors. Okay, the first one we have already understand that what is systematic errors, and we already have seen that the reason behind the systematic errors. Now we see that what is random error. Okay, now let's see what is random error. Okay, so the random errors are those errors which occur regularly. Okay, which occur regularly and hence are random with respect to what? Sign and size. With respect to sign and size. So this type of errors are those errors which occurs regularly and hence random with respect to basically its size and its sign. Okay, and if we give its example, you see when the same person repeats the same observation, you already and regularly have seen that when you repeats same type of observation, you may have got different type of measurements or different type of results. And the reason behind this, the reason is this type of random errors. Got it? For this type of random errors, we have got different result or different measurement values when we repeat the same observation. Okay, and what is the reason behind this? Reason behind random errors? Basically, this arises due to random and unpredictable fluctuation in the experimental condition. Okay, the reason is this type of errors due to random and unpredictable fluctuation in experimental condition, and that's why this type of errors, basically random errors, will arise. Okay, I think you may understand what is systematic error and what is random errors. Okay, now the another interesting thing is as least count error. Okay, least count error. So first of all we want to see what is least count. Okay, So first of all, we see what is least count. So you see, least count is the smallest value that can be measured by the measuring instrument. Okay, by the measuring instrument, the smallest value that can be measured, and this is called least count. This is called least count. And now see, what is least count errors? You see, this is the errors associated with the resolution of the instrument. Okay, this is the errors associated with the resolution of the instrument. Okay, you see, the least count of a normal scale. Okay, the least count of a normal scale is about 0.1 centimeter. Okay, and the least count of a vernier calipers is about 0.01 centimeter. Got it? So we see what is least count. That least count is the smallest value that can be measured by the measuring instrument, is also called the least count. And also we have seen that the what is least counter. So least count error is the error associated with the resolution of the instrument, and we see that the least count of a normal scale is about 0.1 centimeter, and as well as the least count of a vernier scale is about 0.01 centimeter. Okay, now let's see this figure. So this is the normal scale. Okay, this is the normal scale. So you see that here 10 portion between 2 and 3. You already have seen that or already known. So when someone asks you that find 2.5 centimeter, okay, so that's fine. This one is 2.5 centimeter. Okay, fine. Now when someone have asked you that find 2.56 centimeter, now you see that this one is 2.5, and along with this one is 2.6. So you see that I zoom in that this one is 2.5 and this one is 2.6. So someone will have asked you that find 2.56. So that value must be in the middle portion of these two lines. Okay, but when you find with this type of scale, but this one have most harder, because the line is more closer to each other. Okay, so when that type of errors will arise, basically least count errors. Okay, and you see in this type of vernier scale, you see that when you see two scale, this one scale and this one scale. Okay, when this 0 and this 0 is in the straight line, then we have said this has no errors, means this has 0 errors. But if this line means this scale 0 line and this means this scale 0 line is not in the in straight line, then we call that this has not 0 error. Got it? So we have seen also some example here. Now you want to say that how to minimize this least count error. How to minimize? So you see that take some several observation and then average all the observation. Okay, then this least count error will be minimized. Okay, I repeat, take several observation. You will take some several observation, and and after that you will average all these observation, and after that you will minimize this least type of error, or sorry, this least counter or this type of error. Okay, got it? Next we will discuss three important type of errors. Okay, so see which three type of errors. First one is absolute error. This one is first, and the second one is relative error. Okay, relative error, and the third one is relative percentage error. Okay, so first of all we want to see what is random errors. Okay, so we want to see what is random error. So you see the magnitude, okay, the magnitude of the difference between the individual measurement and the true value of the quantity is called the absolute error of the measurement. So I repeat, the magnitude of the difference between these individual measurement and the true value of the quantity, and this difference is also called the absolute error of the measurement. Okay, this is called the absolute error of the measurement. Okay, and this is denoted by some modulus value of del A, and it will always positive. Because you see that here we have denoted it that by the modulus value. That's why we will always it will always be positive. Okay, so this is the absolute error del A. Suppose here some values like A1, A2, A3 dot like AN, some values. First of all, you need to find A mean. How? Just add these values dot plus AN divided by number of values. Here number of values how much? N, because here we last the value is AN. Okay, so we find A mean. Now if I want to find del A1, del A2, del A3, how? So like del A1 is A1 minus A mean. Okay, and del A2 is A2 minus A mean, and as well as del A3 is A3 minus A mean. Easy, fine. Dot like this in this way. Okay, now we want to find this del A. Okay, now del A is modulus value of all the del A1 plus del A2 plus del A3 plus dot plus del, just up to this. Okay, so in this way we can find the modulus value of del A of these quantities like A1, A2, A3 dot AN. Okay, and in this way we find the modulus value of delta A. Okay, so this is the absolute error. In this way we can find this. Okay, see the next thing, and you see the next thing is the next thing is relative error. So what is relative error? So you see that the relative error is the ratio of the mean absolute error del A mean to the mean value A mean of the quantity measured. Okay, of the measured quantity measured. So here we can write the relative error. The relative error equal to del A mean, the mean value of del divided by only A mean. Finish. Fine. So in this way we can find the relative error of these quantities like A1, A2, A3 dot dot n. Okay. Fine. Next we can find percentage error. So the question is how? So you see that the percentage error is when the relative error, the percentage error is when the relative error is expressed in percentage is called the percentage error. Okay, when this relative error is expressed in percentage, okay, into 100, okay, thus into 100 into which? Into relative error. Okay, 100 into relative error. Got it? And this one it is denoted by delta A. Okay. Okay. So in this way we can find the relative error and absolute error, and here we can also find the percentage error, and it is also denoted by this delta A. And you see that the delta A is del A mean divided by A mean into 100%. Got it? So in this way we can measure these three type of errors like absolute error, percentage error and relative type of errors. Got it? Okay. Now you see here one question that repeated observation in an experiment gave the values, these 8 values here given, and here asked that calculate the mean value, absolute error and also relative error and percentage error of these values. Now find all of you. Here you see the question that repeated observation in an experiment gave the values this much, and calculate the mean value, absolute value, relative error and the percentage error. Find all of you. All of you, those who are in live. Do it as fast as possible. Those who are in live, kindly do it. Here you see in the screen the question here. Here you see the question, the repeated observation in an experiment gave the 8 values you have seen here, and calculate the mean value, absolute error, relative error and as well as the percentage error. Do it, all of you. So you see that we can numbering this one is A1, A2, A3, A4, A5, A6, A7 and A8. So these are the 8 values here. Okay, now we can find here A mean. Okay, how? Just like add these 8 values and divided by 8. So here 1.29 plus 1.33 plus 1.34 plus 1.35 plus 1.32 plus 1.36 plus 1.30 plus 1.33 and just divided by 8. Okay, and you have got 1.3275 and you have written this as 1.33. So we have got the value of A mean. So the A mean is 1.33. So now del A1 is A1 minus A mean. Okay, so A1 is 1.29 minus 1.33. Okay, so this one is minus 0.04. Okay, now del A2 is A2 minus A mean. That means 1.33 minus 1.33, that is 0, as well as del A3 is 0.01. You can find it, that is 0.02, and del A5 is minus 0.01, and del A6 is 0.03. Okay, and as well as del A7 is minus 0.03 and del A8 is 0. Got it? Now we can find del A mean. Okay, just add these values like del A1 plus del A2 plus dot dot dot, all these values plus del AN and divided by 8. Okay, and you have got 0.17, sorry 0.0175, and this is 0. We can write 0.02. So we have got that A mean is 1.33 and del A mean is 0.02. Okay. Okay. Now I remove the upper portion. Now we can find the relative error and as well as the percentage error. Okay, and we already find the A mean value and the del A mean value. Okay, so let's see. Okay, okay, so therefore the relative error is del A mean divided by just A mean. You already have known that, and the del A mean value is 0.02 and the A mean value is 1.33, and you can find that the value is 0.015. Okay, so we have already find the relative error, which is 0.015, and the percentage error is there, and you see that this element is absolute error. Okay, you already understand. So the percentage error is just 0.015, means relative error into 100. Okay, so you have got 1.5% just. Okay, finish. So here we see that how we can find the relative error, absolute error, and as well as the percentage error of these observation of the experiment of 8 values. Okay, and we can find that the del A means the absolute error is 0.02, and the relative error of this observation is 0.015, and as well as we can find here that the percentage error is near about 1.5%. Okay, I think you may now understand that how we can find these 3 errors like absolute error, relative error, and as well as the percentage error of the observation. Okay, okay, fine. Now the next one is the combination of errors. Okay, and this one is also important for the numerical part. You see that what is combination of errors. Okay, sorry. So see, what is combination of errors? So here some rule. Okay, so the rule one is when two quantities are added or subtracted, the absolute error in the final result is the sum of the absolute error in the individual quantities. Okay, so this one is the rule number 1 for the combination of errors. So suppose two physical quantities like capital A and capital B have measured values. This one is A plus minus delta A and B plus minus delta B respectively. Okay, we have taken suppose. Okay, so here del A value and del B value are the absolute errors. Okay, and for addition, the maximum possible error in Z is del Z equal to del A plus del B. Okay, and for the difference we have written this, that del Z equal to del A minus del B, and here we can written these two equation in one equation, that del Z equal to del A plus minus del B. Got it? So this one is the rule number 1 of combination of errors. Got it? Now let's see the rule number 2 for the combination of errors. So you see that when two quantities are multiplied or divided, the relative error in the result is the sum of the relative error in the multipliers. Okay, the relative error of the multipliers. Okay, so here said that when two quantities are multiplied and divided, the relative error in the result is the sum of the relative errors in the multipliers. Okay, suppose we have taken that Z equal to A into B, suppose, and the measured values of A and B are similarly small a plus minus delta A and B plus minus delta B respectively, and we can find that the maximum relative error is supposed to be in this way, that the del Z divided by Z is equals to del A divided by A plus del B divided by capital B. Okay, so this one is the rule number 2 for the combination of errors. Okay, next one is the rule number 3 for the combination of errors. So you see that the relative error in a physical quantity raised to the power small k, and this is the k times the relative error in the individual quantity. Got it? And suppose we have taken this equation that z equal to a to the power small k, which is supposed to be the equation is z equal to a to the power means capital A to the power small k. Then we can write here that the error is del z divided by z, that equal to small k into del A divided by A. Okay, and this is the rule number 3 for the combination of the errors. Got it? So here we can find that the del z by z, that is equal to small k into del A divided by A. Okay, now here you see the one question is find the relative error in z if z equals to a to the power 4 into b to the power 1/3 divided by c into d to the power 3/4. Those who are in live now, all of you try this equation. Okay, those who are in live now, you see the question that find the relative error in z if here is the relation that z equal to a to the power 4 into b to the power 1/3 whole divided by c into capital D whole to the power 3/4. Those who are in live now, try everyone, try it. Most important type of equation. If you can do this, then in entrance or G or NEET, whatever it may be, you can find the values or find the errors of relative or percentage, whatever it may be, then you can find it. Okay, now try it. Those who are in live now, all of you, try it. Here you can see the question, find the relative error in z if z equal to a b to the power 1/3 whole divided by c into d to the power 3/4. All of you. Calculate, all of you. I know you can find it. So all of you can try it. So here the relative error del z by z, that is equals to 4 into del A divided by A plus 1/3 into del B divided by B plus del C divided by C, because there is no power in the C. Okay, so plus here the power of D is 3/4, so plus 3/4, the coefficient of D is 3/4 into del D divided by D. Okay, so in this way you can find the relative error in Z if there is a relation between Z, A, B, C, D or whatever it may be. Okay, so in this way you can find the relative error. And when someone says that they find the percentage error, just nothing, just del Z by Z, after the calculate del Z by Z, just into 100%. Now this one is percentage relative error. Okay, I think you may have got it, how you can find the relative error and percentage error. Okay, So now here is one question here. You can see the screen and as well as the question here, that the period of oscillation of a simple pendulum is t equal to 2 pi root over L divided by G, and the measured value of L is 20 centimeter, known to 1 millimeter is accuracy. Okay, accuracy here means del L. Okay, so del L here is 1 millimeter, and time for 100 oscillation of the pendulum is found to the 90 seconds using a wristwatch of 1 second resolution. And so the question is, what is the accuracy in the determination of G? All of you, those who are in live now, all of you try it. Each and every one, try it. Those who are in live now, all of you can try this. This is the most important question for JEE and NEET experience. All of you. All of you can try this. This is the most important question, and after that you can find this type of question. So try it, all of you. Those who are in live, all of you can try this. Here the given the period of oscillation of a simple pendulum is t equal to 2 pi root over L. Root over L. Here root over is the whole function. Okay, 2 pi root over L by G, and the measured value of L is given, del L is given, time is given. Okay, so all thing is given, and you can now find it what is the accuracy of the determination of small g. First, everyone, those who are in live, try it. So you see that the relation is t equal to 2 pi root over L divided by G. Okay, now square both sides, t square equal to 4 pi square into L by G. From here G equal to, because we want to find the accuracy of the determination of G, that's why we can here we find G value. So G equal to 4 pi square into L divided by T square. Got it? So from here del G by G value is del G by G equal to, we can write here that del L by L plus 2 into del T by T. Okay, so just del G by G equal to del L by L plus 2 into, for the power of T square, plus 2 into del T divided by T. Now just put all this value. Okay, so del L is 1 millimeter, so that one is 0.1 centimeter divided by 20 plus 2 into here 1 second resolution, so del T is 1 divided by T is 90 second. Okay, this one is T and this one is del T. Okay, this one is 90. Okay, so from here the value is, you can find it the 0.027. Okay, so this is the relative error. So here the question is, what is the accuracy? So that means we want to find the percentage relative error. Okay, so del G by G is into 100%, that equal to 0.027 into 100%, and we can find the value is 3%. So that is the accuracy in the determination of G. Okay, I think you may now understand that how you can find this type of accuracy of determination of this type of values. Okay, I think you may now got it. Those who are not understand, kindly take a screenshot of it. So we can find here the accuracy in the determination of G is near about 3%. Okay, so the accuracy is 3%. Okay, so here you can see one question that is for your homework. Okay, this question is for homework. Those who are in live now, you can note down this question. This one is NEET wala question. Here question is, if error in the measurement of radius of a sphere is 2%, and then what will be the error in the measurement of its volume? Okay, so we want to find the its error in the measurement of the volume, and the given is the error in the measurement of a radius of a sphere is 2%. Okay, that is given, and you can see here the four options, that 4%, 6%, 2%, or either 8%. Okay, so this one is homework. Okay, okay, everyone note down this. Those who are in live now, everyone note down this. This one is for homework. Okay, so আজ এতটুকুই। দেখা হচ্ছে খুব শীঘ্রই পরের ভিডিওতে। ওকে, পরের যে ভিডিওটা থাকবে সেই ক্লাসে আসবো, এই আজকে যা পড়ালাম সেই রিলেটেড কিছু এমসিকিউ নিয়ে আসবো। ঠিক আছে, নিটস এবং আইআইটি জি রিলেটেড যে সমস্ত এমসিকিউগুলি আছে সেই রিলেটেড কিছু এমসিকিউ নিয়ে নেক্সট ক্লাসে আমি আসছি। খুব শীঘ্রই দেখা হচ্ছে পরের ভিডিওতে। আজ এই পর্যন্তই। স্টে টিউনড উইথ সিম্বায়োসিস। গুড বাই।